So welcome everybody. Michele is here with us and going to talk about the OpenTelemetry resources. I think that's one of the very powerful aspects of OpenTelemetry, so I'm really happy that he's here to give us a talk about it. The chat should be open for everybody. There is the chat, there is the Q&A. Don't hesitate to make comment, ask questions. If there's reference, I'll try to send a link so that you have it. And yeah, Michele, over to you.
Hi, thanks for having me here. This talk is going to be about OpenTelemetry resources, and it is a topic that ties in very nicely with some of the things that Idris said in one of the previous sessions about cardinality and metadata, for example, for matrices, and Adriana was mentioning as one of the pain points in terms of consistency of metadata when trying to adopt OpenTelemetry in large organizations. My name is Michele Mancioppi. I am a product manager at Dash0. We are a relatively new group of experts that are working on making observability easy for developers. I have been in the space of observability for about a decade. You can find me on social media, but I'm not posting much serious content. I mostly troll. So today we are getting started with a rather philosophical approach to looking at telemetry. And specifically, what are we looking at on the screen? When we take this line chart at face value, what do we see? The line is red, so maybe it means something is not good, like, I don't know, maybe an error count or an error rate. It has spikes. Spikes are notoriously bad. It does look a bit like a time series, so probably it is. And the line chart tapers off at the end, so maybe things get better. Not quite. It's actually not a time series at all. It's not even related with DevOps. And it's probably one of the funnier charts with the red color that you're going to interact with on any given day. So if there is one thing that you should bring away from this topic is this: telemetry without context is just data. And what do you need to know when you're confronted with telemetry, when you are using your tools to query data? What do you need to know about it? First of all, what does the metrics or the spans or the logs, what do they mean? What do they represent? What is the type of data that you collect as HTTP response count? And where is it coming from? From which systems? Which systems does it describe? There is also another way of talking about context, a very technical one, in the way telemetry is different types of signals, like traces and logs and metrics are related with each other, but today we stick with the context as in systems. Moreover, you need to know whether the telemetry you're looking at is accurate, and what does it mean? So when is it good? When is it bad? Ideally, you would have a clear idea of that. So as I said, today we stick with the definition of context about which system is being described by the telemetry that you're looking at. And when we think about which system we're looking at, there is effectively a kind of pyramid to the way we think about it. We tend to start with the where. Is it on which cloud, which account, which region, which data center? Is it a system under my desk? Which platform? So container orchestration. Is it running on Kubernetes, on ECS? Is it running on just on a naked virtual machine on EC2? And then we start thinking about the compute aspect. So is it a containerized process? Is it maybe a managed service? What is the process ID? Which runtime it is in? Which version of the runtime, and so on. Keeping going up stack from something like the closest to the silicon to the more logical level, we look at the architecture. So which logical component is it? Is it the front end of my checkout service? Is it something else? And last but not least, who's on the hook for it? Who runs the component? Who's responsible for making sure that the component is not going down? When there are problems, who are you going to call? All of these things are part of our definition of a system. But before we look at how these things are modeled in OpenTelemetry and how you can make use of them, we have a couple of interludes. First one is biblical. We start looking at one of the stories that has always fascinated me. It is the Tower of Babel. The Tower of Babel is effectively a story about how humanity had banded together, united by a common language, not to suffer a second flood. So they built a city and a tower that would be immune to being flooded. And then God said, these people are being too effective. Let's give them a lot of different languages so that they can no longer understand each other and their joint effort will flounder. And it worked. The Tower of Babel did not work anymore. And I think it's an excellent allegory for the #1 problem in computer science and software in general. It is the hardest problem that any of us has ever faced. And yeah, it's people. Specifically, it's how people do not understand each other enough to make stuff work properly and consistently, the larger the organization grows. A second interlude is about Discworld. Now, Discworld is a fantasy series by probably one of the best authors of all time, Terry Pratchett. And in the series, there are a lot of interesting characters and people, but I always prefer the dwarfs. Specifically, the dwarfs are very argumentative. And Terry Pratchett said that whenever you have 3 dwarfs in a room, you probably have at least 4 opinions. And this quote came back to me while I was preparing the talk, and it took me a bit to put my finger as to why that was happening. And it's because it actually mirrors very clearly one of the main issues that I've seen in several organizations when adopting telemetry. So now let's start looking at how the Tower of Babel and the issues with very opinionated dwarfs are affecting us in our daily work. And that is something that they call the metadata drift. As we collect different types of signals, metrics, logs, traces, and spans, very often the collection methods are different. You may have traces and spans and maybe some metrics and some logs coming from OpenTelemetry SDKs embedded in your applications, but you may also have metrics coming from Prometheus endpoints exposed by your Kubernetes cluster or by managed services like WSS3. Maybe you are importing data from CloudWatch. The same, you have logs that may come from, I don't know, FluentD running on your EKS cluster, which is actually sending a completely different set of metadata to the backend. And even for the simplest things, there's always a great risk of using different names for the same concept. I was very impressed when once visiting a former team I used to be part of. They were telling me how difficult it was across I think there were 5 or 6 development teams to actually align on using the same key for the metadata representing which AWS S3 bucket the data was in. So here I'm showing only 3. In reality, there were 5 teams and 7 different ways of creating that label and formatting the value, for example, the capitalization, across all the various applications that were operated by those people. So this is where I created effectively my own quote by saying that any 3 developers going about their business will always end up having at least 4 names for the same thing. This is actually a very serious problem because something that happens very often, especially with open source orientated organizations, is that you are storing different types of signals in different unrelated databases. And when you are performing your investigations, when you're troubleshooting and triaging, you seldom get to the bottom of it just by looking at one type of data. You may start with traces and end up looking at logs, or you may find issues in metrics and then try to explain those metrics based on the sample spans you have in the trace backend, and then from there logs. So it's always like a very dynamic investigation, very multifaceted. And if you do not have common metadata, in particular about from which system the data is coming from, effectively the only thing that you have in common are timestamps. Assuming that your timestamps are, for example, all in the same time zone, which is not always the case, and that there is no significant clock skew. Well, I've seen sometimes serious clock skews, which made it even harder to find out which logs matched which spike in metric, for example. So another thing they should bring away from this talk, your timestamps always in UTC, no matter where. As you can imagine, trying to search data across all these different databases when you don't have a common language in terms of metadata to filter and look for, it's not fun. And it actually adds measurable amounts of time to your minimum time to understand what the issue is. So there must be a better way, right? Yes. And that better way is courtesy of OpenTelemetry. OpenTelemetry is the second largest project of the CNCF Foundation. It was founded by two different open source projects for observability, open tracing, and open census. They came together and said, we need to make the one true project. And they kind of succeeded. OpenTelemetry is nowadays effectively the de facto standard for distributed tracing. There is very good progress in achieving good interoperability with Prometheus. And also in terms of logs, most log agents can send data to an OpenTelemetry backend. One of the parts that I like the most about OpenTelemetry is semantic conventions, which is effectively giving you that shared dictionary of names to use to describe your systems. And OpenTelemetry has a lot of conventions that apply to all the signals, traces, metrics, logs, as well as their common ground, the resource. Now, before we get into the concept of resources, and we will do at length, let's have a look at how the semantic conventions of OpenTelemetry map to the pyramid of layers when we talk about systems. So, for example, at the level of the infrastructure, you have the cloud semantic conventions that allow you to tell you which cloud provider, which cloud region, which cloud account, availability zone, and so on. At the level of the platform, there are very comprehensive semantic conventions to describe which Kubernetes cluster, namespace, deployment, pod, which type of other orchestration you may be using. It may be Heroku, maybe something else. You can get at the level of compute, collecting very easily metadata about which runtime it is, which version, which process, which container, which operating system, and so on. One of the interesting parts is that the architectural part, when you talk about which service it is, it's actually built in. Every OpenTelemetry SDK will set a value for the service. Maybe a default one, but it's there. And that tells you just how important the logical level of describing from which part of your architecture is this telemetry coming, how important it is, how central it is. One thing that OpenTelemetry doesn't have is semantic conventions to describe how the components are spread across your organization. But effectively, what you're doing, for example, nowadays for AWS tags in terms of cost center and team, you can reuse one-to-one. Now, how does it work to actually use these fantastic semantic conventions to add context to OpenTelemetry instrumented applications? Now, finally, what is the definition of a resource? A resource is a set of key value pairs that are describing the system that is providing you with telemetry. In the case of the Kubernetes, a pod running on Kubernetes, I tell you which pod it is, which container, which runtime it is, on which cloud it's running, and so on and so forth. This is an example of how resource attributes look like in these actually are attributes. They look like in reality. This is the kind of things that you would find on a log record. So the way that OpenTelemetry shows logs. In OpenTelemetry, metadata are always key value pairs. You have the key is always a string, and that is where the semantic conventions are establishing all these names. And the values can be a lot of different things. They're usually strings, but in some cases you may have booleans or numbers or even arrays and maps. Although in reality, I've never seen them used. Metadata in OpenTelemetry are at multiple levels. So you can have metadata at the level of the spans and the events on the spans. Think of them kind of as logs directly associated with a span. You can have them on span links, which are pointers to spans in another trace. Very handy if you're doing messaging applications. You have metadata on metrics data points, where, for example, you would specify the unit of measurement. You have metadata at the level of the log record. For example, was this log emitted over a standard error or standard output, or from which file did we read it? And then there is metadata at the level of the resource and the scope. The scope is very technical. It's about kind of the things you would find in terms of instrumentation and tracers. So usually people don't think about it much, but resources are probably the best way that you have that metadata about your system. And when you compare the kind of metadata that you would have in resources as opposed, for example, to a log, on the left-hand side, you see a snippet of resource attributes. They are talking about which Kubernetes pod is emitting the data, while the logs are about the single data point, the single log record. How do you go about setting and improving the resource metadata in your telemetry? There are principally three ways. You have that data being collected by your instrumented application. This is where we talk about manual hard coding, where you set them in your application initialization, or you use a concept called resource detector. You can configure by a process environment and soon a configuration file format, additional resource attributes, as well as other settings. In OpenTelemetry, most important settings are something that you can set in the process environment. Or, and Iris was talking a lot about it, the OpenTelemetry collector can add, remove in some cases, improve, standardize, normalize your resource metadata in flight. These methods are not mutually exclusive, and we will discuss later in the talk when you should use what for which purposes. So when you actually want to embed the resource attributes to have them in the telemetry that your application produces on the get-go, you can either code it. You see that that resource, it's effectively created with already the attribute team set to awesome, or you can use resource detectors in the line above, which you can customize for the kind of environments you expect your application to run in. In this case, this Node.js snippet was expected to run on ECS, so I built in the AWS ECS detector. When you work with distributions, so versions of OpenTelemetry that are customized by vendors, often they will do a lot of the initialization of resource detectors for you, because the SDKs themselves don't do so much, and resources are so important. If you are doing the SDK yourself, that is a great way to improve the quality of your data. You can set by environment variable, and here you see an example that is taken from the OpenTelemetry demo Helm chart, where you see how the deployment over Helm is setting some of the fundamental attributes like the service name and the namespace. And with the OpenTelemetry collector, that is the final method, probably the most powerful one, you effectively are, so your application is sending telemetry to the collector. The collector takes the telemetry, patches it, samples it, aggregates it, modifies it, and sends it downstream to your observability backends. And that is the place where you can do a lot of the enrichment, normalization, and improvement of your resource attributes. I listed on the slide a few of the processors that are very often used to manipulate resource attributes. The first one, the Kubernetes attributes processor, is looking at the telemetry coming in, looks for the Kubernetes pod UID or pod IP, and then it uses that data as correlation to say, okay, it's coming from that pod, therefore I can add all the metadata about the namespace, the deployment, the replica set, and so on. It's very powerful. You can also do a lot of things manually. For example, I've set up several times dropping some metadata directly in the processor, or maybe sampling some of them. It's something super powerful you should look at. Last but not least, the semantic conventions are many and they're evolving, in particular also because there is additional standardization going on with the Elastic Common Schema, which is another set of semantic conventions that was created by Elastic. So as the semantic conventions evolve, some formats of some attributes change over time, and the collector gives you a way to translate data in older formats into a new one. And that is amazing to effectively achieve the consistency you need in terms of resource attributes without modifying the code of the applications deployed. Very powerful. Since we're talking about the OpenTelemetry collector, it's very powerful and its configuration is a bit complex. So at -0, we built something open source to help with that. We call it the OTel bin. It allows you to visualize, edit, and validate against various distributions your configurations for the OpenTelemetry collector. If you're dealing with complex OpenTelemetry collector configurations, give it a try. Now, we've seen the three main ways of adding and manipulating resource attributes. You start with hard coding or resource detectors. That is the preferred way to make sure that you have as much metadata as possible in terms of resources. There is a lot of metadata that your application will be able to understand from where it's running. For example, if you're running on ECS or EC2, there are metadata endpoints that are exposed, available to your application as HTTP, and metadata in there, like what is the ARI, the Amazon resource name of this resource, is something you can automatically look up and automatically set up in your application just by enabling the correct detector. When you cannot modify the applications, or for example, the data you need is not visible into the application. For example, it's very hard from inside the Kubernetes pod to know which deployment deployed it. Then that is the case where you take the OpenTelemetry collector and modify the telemetry in flight. Last but not least, you can use configurations with the OpenTelemetry resource attributes, but they're very prone for errors because configuration tends to be very distributed in many different places, and in large databases, it's kind of hard to keep them well aligned. So if you can avoid the minor configurations, don't do that. Stick to the programmatic one. They are less error prone. This brings me to pretty much the end of the talk. If you're interested in collaborating and improving the way that OpenTelemetry goes about describing the systems that emit telemetry with resources and semantic conventions and so on, here on screen there are a few pointers. I do mostly product management nowadays, but going and improving some resource detectors is kind of my happy place for TGI Fridays. So I find it a very rewarding thing, because at the end of the day, the better metadata for the telemetry, the more useful the telemetry is. And a few small lines of code changes are actually improving the troubleshooting for a lot of people out there. Cool. Now let's sum up what we discussed. Telemetry without context is just data. When you look at telemetry, you should know very well where it's coming from, which systems it is about. For example, you should not wake up at 3 a.m. in the morning because dev or QA are down. You should know it's coming from prod, and then that is when you actually stand up. That is what you use OpenTelemetry resources for. People are people, and keeping people consistent in the way they do things is hard. That's where OpenTelemetry semantic conventions help. And the implementations of the semantic conventions in terms of resource detectors and the OpenTelemetry collector help even more. And yeah, that's about it. If you would like to chat more, I'll be with my pals of @KubeCon. So pass by and say hi. And let's see what the questions are.
Yeah, perfect. Thank you. Thank you so much. That was really, really interesting. Yeah, we have 5 minutes for questions. So if you have any questions, put them in the chat or in the Q&A section. And while we wait for people to think about it and embrace it, I have a question. So we are talking about all the advantages of semantic, of those attributes and of that normalization and standard language. Is there any downsides to using too much of them, being from an overhead perspective or from a security, privacy? Is there any downsides to them or things you should be careful about?
I mean, the answer for something like this is, of course, it depends. But what it depends on is a few things. Not all tools are equally good at dealing with a lot of metadata in your application. There are, of course, storage costs, but also querying costs, especially, for example, if the database you have is not columnar or your indexing is not capable of looking up the right data based on some attributes. Sometimes it happens. There is some overhead in terms of transmission, although the way the data is formatted by OpenTelemetry with the OpenTelemetry protocol, you effectively, most of the time, have one attribute set only once and not for every span or log. So that is tends to be very little overhead comparatively. The kind of data that you would put in the metadata to describe a system tends not to be governance relevant, for example, in terms of privacy. Also, not so much in terms of security. So you are not going to see the private keys of something. It's much more common to have problems in terms of security or governance in the metadata, in the attributes that are set on spans, logs, mostly, metrics seldom. The classic example for spans is when you have user IDs or account IDs in the path of an HTTP API. So the span representing the fact that you're serving a specific request may contain attributes, may contain data about which user is doing that. Sometimes you see also that data in custom HTTP headers. So for example, if you're using authentication schemes that are being a bit creative in terms of which HTTP headers you set, that is commonly the case. But probably the worst offender is logs, specifically log bodies, especially because logs are usually the first thing that you put in an application. And very often we still nowadays tend to do logs in an unstructured fashion, meaning that instead of sending to the OpenTelemetry SDK the log pattern and the specific attributes, which are then easier to drop in the OpenTelemetry collector, like if you have a user ID, probably you're not sending that to the backend, or if you do, you're hashing it so that you can find out all the things that one specific user did without knowing who that person was. Yeah, logs are usually the worst.
Thanks. And so I really liked also that we were talking about the aspect of organization, maybe having some data about the teams. So that would be, it's not something that's included in OpenTelemetry. So that would be something for an organization to decide together on how to organize them.
It is.
Do you have any recommendation for those teams in how to approach that?
I'm very opinionated on the subject. I used to work at probably the largest software vendor in Europe, and I have seen just how hard it is to make 3 people agree on how to name something. It is like the worst cat herding that you could possibly imagine. I am of the persuasion that most of the collection of telemetry should be entirely automated, and the management and normalization of the metadata should be centralized. This, of course, poses a challenge in terms of scale. Sometimes it's easier to sample or select the right telemetry in the application, but that also has a cost, because all of a sudden your engineers not only need to be experts in whatever the business logic of their application is, but now they're also observability experts to know how to create spans that look good. And it's right. I cannot say I espouse the point of view that you should write your own instrumentation often. There are some cases where that makes sense, but most instrumentation is really boring and getting it right is not easy. So I am the kind of person that relies very heavily on heavy automation in the collection of telemetry. And that makes it much simpler to have consistent metadata, because the same agent or instrumentation is going to produce similar and comparable metadata, irrespective of which team has deployed it.
Yeah, thanks. So last question from the audience, and then we're going to have a break. So today we have a tracing in X-ray, metrics in Datadog, logs in Splunk with no consistent metadata. What is the best way to create a more integrated experience for troubleshooting?
Oh my. Here we are having two problems of having the data not well integrated. The first one is that the data sources that you're mentioning are not correlating data. When you're looking at metrics in Datadog, you're not going to find a link for looking at the right traces in X-ray. Logs in Splunk, same. All of the tools that you're mentioning have a rather comprehensive support for the classic signals, so metrics, traces and logs. If it's not it's not possible for you to standardize on one tool, which is a very common thing, then it becomes a rather expensive exercise of driving an organization-wide initiative to clean up the metadata. That is something that can be a bit daunting, especially because when you're, for example, putting logs in Splunk, those logs very often, they're not just there for monitoring, the so-called DevOps use case, but they have security and compliance use cases sometimes associated with them. So in my experience, what the kind of semantic conventions that you may be using in your organization, if you are going for a standardization, what you have in logs tends to be the one that wins. So my advice would be, if you're using Splunk for more than just querying logs, but you have also the security and governance colleagues looking at it, take those semantic conventions and try to standardize the other signals around it.
Thank you so much. So we are at the end of the session. Thank you so much, Michele. That was really insightful. We have a 30-minute break. Take advantage of it because we have lots of great sessions coming up next. So take a break, get something to drink, something to eat, and we'll see you in 30 minutes. Thank you.
Bye, everyone. Have a wonderful conference.